Today, we're diving into an AI model that's teaching machines to see our world with, honestly, breathtaking clarity. We are talking about DINOv3, and it learns in a way that's, well, it's radically different. So just imagine this for a second. What if an AI could learn about the visual world kind of like we do? Not by being spoon-fed millions of images that have been painstakingly labeled by humans, but just by watching, by observing the world and figuring out the patterns all on its own without anyone ever telling it, hey, that's a cat, or that's a car.
This whole idea is the magic behind a super powerful technique called self-supervised learning, or SSL. Basically, it's a method where the AI learns directly from the raw data itself. And that is a total game changer. Why? Because it means we can train these AIs on a practically unlimited, uncurated flood of images from the web, unlocking a scale of learning we've just never seen before.
Okay, so SSL is obviously incredibly promising. The next logical step was just to scale it up, right? Bigger models, more data, what could go wrong? Well, as researchers started pushing the limits, they ran into this really bizarre, kind of counterintuitive problem. Let's get into what they call the big model paradox. Here's the paradox in a nutshell. The bigger the models got and the longer they trained, the worse they got at seeing fine details. It's wild. Their high-level understanding of a scene was improving, sure, but their vision was, for all intents and purposes, getting blurry. And this chart just lays the problem out perfectly. It's based on the findings in the paper, and it shows that for high-level stuff like classifying an entire image, performance just keeps climbing the more you train it. But look at that second bar. For a task that needs a real detail, like segmentation, the performance actually peaks early and then starts to drop. The model was literally unlearning how to see the little things.
So, what does that actually look like inside the AI's brain? Well, on the left, early in the training, its internal features are sharp. They're well-defined. It can clearly tell different parts of an object apart. But on the right, after all that extra training, it's a mess. The features become noisy, confused. The paper calls them degraded, where irrelevant parts of the image just get all jumbled together.
So, this is the big question, right? How do you fix this? How do you get all the incredible benefits of scale without making your AI's vision all blurry? This is where the Meta AI team behind DINOv3 came up with a solution that is just truly elegant. Let's get into its secret sauce. They call this technique gram anchoring. And here's the gist of it in 4 simple steps. 1. The giant AI model starts chugging through massive amounts of data. 2. Just like we saw, its detailed vision starts to get noisy. Now, here's the brilliant part. Step 3. The model gets anchored to a snapshot of itself from earlier in the training, back when its vision was still crystal clear. It's like reminding the AI, hey, remember this? This is what sharp details look like. And the result? Step 4. Its vision is restored and sharpened right up.
And hey, this wasn't just some tiny little tweak. Let me quote directly from their paper. Quote, the late application of LGram still manages to repair very degraded local features. Think about that. The technique is so powerful it can actually reverse the damage, even after the model's vision has already started to go downhill.
All right, so with that paradox solved, the team could finally unleash the full power of scaling these models up. So the question is, how well does DINOv3 actually perform in the real world? Let's look at the results and really put its vision to the test. I mean, the difference in quality is just night and day. While older models gave you features that were pretty good but often kind of noisy, the researchers described DINO3's features as fundamentally superior. They're sharper, they're cleaner, and they have better semantic coherence, which is just a fancy way of saying the AI has a much clearer, more organized understanding of what it's actually looking at. And that visual sharpness, it translates directly into some absolutely state-of-the-art performance. Let's take semantic segmentation, this incredibly hard task of labeling every single pixel in an image correctly. On a major benchmark, DINOv3 hits a score of 55.9. That doesn't just squeak by its predecessor, it actually outperforms other highly specialized models that were built just for this task. That's how good its grasp of detail is. Okay, what about just finding objects in a scene? On the classic Coco benchmark, it hits a stunning 66.1, a new record. But how it does this is the really crazy part. It sets this record using a frozen backbone. That means the core of the model isn't even retrained for this specific task. That makes it ridiculously efficient and versatile. And it's not just limited to flat 2D images either. The model shows this really profound understanding of 3D space. Whether it's matching points on an object from different angles or finding similarities between totally different objects,
DINO 3 has a much stronger grasp of both geometry and meaning than anything that came before it.
So, yeah, we're seeing record-breaking numbers pretty much across the board. But the real impact of DINOv3 isn't just about setting new high scores. It's about building an entirely new kind of foundation for all of computer vision. So what makes this a fundamental shift? It really all comes down to versatility and efficiency. Just imagine having one core model that can handle dozens of different visual tasks without all that expensive task-specific retraining. That kind of efficiency is the holy grail. And this one model works on everything, from your vacation photos to satellite images to medical scans. And to make it all practical, the team took all that knowledge from their giant 7 billion parameter AI and distilled it down into a whole family of smaller models, making all this power accessible to pretty much everyone. You know, a breakthrough like this really feels like a turning point. It solves a huge fundamental problem with scaling and gives us this incredibly versatile, powerful, and efficient new tool. So let's just take a step back and ask, what does this really mean for the future of seeing machines?
DINOv3 proved that an AI can learn to see our world in high definition without a single human telling it what to look at. So that really leaves us with one last fascinating question to chew on. What will an AI be able to understand about our world when it can learn not just from curated datasets, but from the endless, unfiltered stream of visual data that exists all around us?